Hello, hello. We are continuing with our study of kinematics. So, last time I told you that the average velocity of an object over a elapsed period of time delta t, where it moved from one place to another. That's a displacement, which I'm calling delta x. If I do delta x divided by delta t, that gets us the average velocity. Okay, so now that we know that, let's talk about instantaneous velocity. So to explain it, I've made another displacement graph here. So the horizontal axis is again time in seconds. The vertical axis is position in meters. And our skateboarder has done this path. So she started at, it's a different example. Okay, so she started this time at negative 20 meters. She's moving in the positive direction. You see a positive slope here. And then slows down and then starts to move in the negative direction. So now for this explanation, let's consider two times and locations. So the first time is at 2 seconds, where she's at negative 10 meters. And the second time we'll think about is 6 seconds. And at 6 seconds, she is at 10 meters. So if I ask the question, what is her average velocity from 2 seconds to 6 seconds from the previous lecture, you know to figure it out, you're going to do delta x over delta t. And so the final position is positive 10 meters. The initial was negative 10. And so you have 10 minus negative 10. So minus minus is positive. Works out to 20 meters. The elapsed time is 6 seconds minus 2 seconds. That's 4. Okay, 20 divided by 4 is 5 meters per second. That's the average velocity. Average velocity. Okay. And if I connect a straight line between these 2 points, that slope is telling us the average velocity also. Now, when I draw a line through a curve like this, this is called a secant line. All right. It's crossing the curve here, and it's crossing the curve here. But I could draw a line which doesn't cross the curve, which just barely touches the curve. Now, in this version of the drawing, my line is not crossing the curve. It's just barely touching the curve at one point. We call this a tangent line. And if I can figure out what the slope of this tangent line is, it tells us the velocity of the skateboarder right at the time where the straight line and the curve touch. So it looks to me that this is going to end up being 3.5 seconds. And that's where this tangent line barely touches the curve. Okay, so it answers the question, what is the instantaneous velocity at 3.5 seconds? Okay, so to figure that out, I need to find that slope. So graphically, one way to figure out the slope of this line is to mark 2 places on the straight line. And here I've marked one at 1.5 seconds, and I tried to look carefully at where that comes out on this graph. It looks like it's at -4 meters. That's where this point here is. And then I put another point here, and it looks like it's at 5.5 seconds. And if you look carefully, 0, 5, 10, 15, a little more than 15, I'm guessing 17 meters. And so now using these 2 points, right, this will be the final time and position. This will be the initial time and position, at least, just for the sake of this particular calculation. So I put in final minus initial. Okay, 17 minus -4. That's going to give us 21 meters. And for the times, final is 5.5, initial is 1.5 seconds. I subtract, I get 4 seconds, and I do the math, and I get that the instantaneous velocity right at this time here at 3.5 seconds is this 5.25 meters per second. So there are many important lessons here, but one of them is that the slope of the tangent line is the instantaneous velocity. Now notice that this slope keeps changing, right? The tangent line keeps changing. So for example, let's say, what's the tangent line look like at 5.5 seconds? Well, it looks like it's horizontal, right? If I try to draw a tangent line for 5.5 seconds, it's going to be right there. And so I can tell you right away that the velocity at 5.5 seconds is 0. And then how about a little later? Let's draw another tangent line. Let's see here if I can do this. The velocity, it's looks like right around 7 seconds. It's whatever this slope happens to be. Now, when you're figuring out these slopes, let me get this out of the way. It doesn't really matter what 2 points you pick. So, for example, for the first tangent line, I could have picked, here I'll use a different color. I could have picked this point here and maybe this point here. And I would have gotten the same answer. I would have still gotten 5.25 meters per second. The numbers would have been different here, but in the end, you would get the same answer, 5.25. You'd get the same answer, except perhaps because you're eyeballing it, you're making approximate estimates of where the points are. They might be slightly different, but it shouldn't be very different. Okay, so I have some questions for you. At what times is the velocity 0 in this graph? So I already mentioned right around 5.5 seconds, and there are 2 other times where the velocity is about 0. I'm sure you can figure this out. And at what time is the velocity greatest? So most positive, let's say. Well, it's going to be where the slope is the steepest. Where would you say that is? Maybe at 2.5 seconds here, maybe is the steepest slope, or maybe at 3. It's a little hard to tell. Okay. And at what time is the velocity most negative? In other words, at what time is the slope going downward the most? What would you guess? Maybe 6 3/4 seconds, maybe 7 seconds, not quite. All right. Okay. Here is another exercise. I'd like you to draw a tangent line at t equals 2.5 seconds. In other words, draw a tangent line right here and draw the tangent line. And then from that, estimate the instantaneous velocity. So once again, I'm going to be making my notes with answers available to you. For Mount SAC students, it'll be in Canvas, and for students around the world, because you love my class so much, it'll be on halverscience.net. So halverscience.net. Now, yeah, okay, so go ahead and go there. Okay, problem number 5. Do the same as the previous question, but at 7 seconds. So what is the instantaneous velocity here? So here, like that. Okay. Okay, so here are, you're going to get 12.5 meters per second, roughly, for number 4, and you're going to get negative 10 meters per second, roughly, for number 5. All right.